Hey everyone, let's dig into the quiz. Question 1, 538 article reports they found a significant link between raw tomatoes and Judaism. It's true, they did. Why is this question on the quiz? Who cares? I want you to think carefully about the difference between a significant link and a meaningful link. And this is one of the main points of the 538 article, which is to recognize that when we look at a lot of variables, as food frequency questionnaires and long-term observational studies necessarily have to account for, you get a lot of statistical noise, and there's going to be correlations that make no sense in the real world. They will be statistically significant, which is what the question asks, a significant link between raw tomatoes and Judaism. That's very different than a meaningful link, as it's something that matters in the real world. And there's no possible meaningful correlation between raw tomatoes and Judaism. I guess there could be, but no. Question 2, headlines tend to report absolute rather than relative risk to make food comparisons more precise. False. As the 538 article says, relative risk is more commonly reported. We see this all the time. People who eat blueberries for breakfast are 3 times less likely to get headaches in the afternoon. Sounds important, right? That's a good headline, 3 times. But that's relative risk. And as the article points out, often the absolute risk doesn't seem quite as cool, right? If the chance that you're gonna, not have a headache because you eat blueberries is 0.03%, right, as opposed to 0.01%, well, that's 3 times, but it's 0.01%. So trivial, right? It's probably not going to affect your dietary habits. But it sounds better, 3 times. Question 3, nutritionists largely disregard studies done with FFQs because of their inaccuracies. False. As flawed as they are, as limited as they are, they're still one of the best tools we have for understanding links between diet and health. Ask people what they ate, evaluate and measure their health, and then find correlations. Does it because something is flawed and we know it's limited in certain ways, and these articles tell you how they're limited, I think, pretty clearly. Just because we know they're limited doesn't mean that we can't use them. It doesn't mean that they're worthless. It doesn't mean that people ignore them. So until we find better tools, until we have better techniques, whatever they might be, these are our ways of learning about nutrition. So nutritionists use these. Of course, they use them with a grain of salt because they know the limitations for the most part. But there's a difference between nutritionists and researchers doing these studies and trying to understand what it means, and then that knowledge or those articles or whatever being written about by journalists, by bloggers, by people that sort of communicate science to a wide audience. There's a lot of room for exaggeration, reporting on relative risk rather than absolute risk. Number 4. The many variables that food questionnaires account for remain one of their biggest strengths. This is false. The many variables make it harder to use in many respects, and that's the point of both the articles. One of the points of both the articles is that there's so many things, there's so many variables. You get more false positives, you get a lot of statistical noise. It becomes harder to find definitive causal relationships as opposed to statistical correlations, right? So it's not really a strength. It's nice to try to account for a lot of things. I mean, you think that, that's a good thing in general. But when you start to account for so many things, finding actual relationships in that very, very complicated ecosystem is difficult. So not really one of the biggest strengths, at least as portrayed by these articles. Question 5, the challenges of diet research means that food cannot be a scientific way of controlling disease. I said the answer is false, but the reason this question is on the quiz is I want you to think about what does it mean to be scientific about controlling a disease, or what does it mean to use nutritional research or dietary research in a scientific way. Just because our knowledge is limited by food frequency questionnaires and the difficulties of observational studies, it might mean it's not accurate or they're not very precise. But it doesn't mean they're not scientific. So scientific means rigorous. It means there's something that's repeatable. You might not get the same results if you do a food frequency questionnaire for lots of different people. Of course, we know that. But that's part of the science. That's part of the method. People understand that already. The idea that you can use foods to better your health in a rigorous, testable, verifiable, repeatable way, absolutely, right? Just because we don't know the actual exact metric of causation or correlation, or we don't know exactly why a certain food seems to be useful, doesn't mean that we can't talk about it scientifically. It might mean we can't measure it super precisely, but that's different. So when you think about the question of how scientific is nutrition research, I don't want you to get the sense that there's no science behind this stuff because it's difficult, or there's so many variables, or people lie on food frequency questionnaires, or people don't report, the correct amounts of food, for instance. That doesn't make it less scientific. It just makes it harder to study. Question 6. Limitations of randomized controlled trials with food make accurate nutrition research almost impossible. 25% got this one right. The answer is false. Accurate nutrition research impossible? What does that mean? Well, what does accurate mean, for one thing? What is nutrition research? Is it the broad longitudinal studies that have a lot of uncontrolled variables, or is it something that's very tightly controlled in a laboratory, which you can do, like isolating the effects of vitamins in certain diseases? Can you do accurate research? Absolutely. But you have to be very careful about the scope and the scale of the research if you want to say how accurate it is. Can we say accurately that certain foods or certain diets result in better health? It depends, right? That's a hard question. But there's a wide latitude of what nutrition research means, and that's the point of this question, is to get you to think about that. These articles spoke very broadly about nutrition research, and they talked about a lot of different kinds of research, but mostly what they were focused on is a kind of nutrition research that associates very, very broad, hard to define diets with health, also hard to define. Question 7. Long-term observational studies can be very valuable because they yield more accurate results than studies based on food surveys. Again, we have this word accuracy, which is hitting us in the face. This was about 2/3 people got it wrong, 1/3 put false, which is the right answer, at least in my view. They're not more accurate. Long-term observational studies have tons of problems, right? What are people really eating? Lots of different bodies eating lots of different foods. You're trying to isolate for a particular food or lack of food. There's so many variables. It's hard to do those studies accurately. They're certainly not more accurate than food frequency questionnaires and other things. They give us a different perspective, right? They are valuable in a way that food frequency questionnaires or food diaries are not, for sure. So it's not the case that there's clearly one method that's better than others. Long-term observational studies would be more accurate if you could sort of go into the hypothetical world from the Vox article about, measuring everybody's intake, having sensors in everybody's poop, and, being able to sort of control exactly what they eat. People can't go outside the lab. You give them the exact same food, like it's obviously totally fictional. But that's the only way you're going to get accurate results. Number 8, nutritional research can be generalized from small groups to large groups because food generally affects humans in the same way. That's one of the big challenges of nutritional research, understanding links between diet and health, because the same foods affect different bodies very differently, depending on what your diet is, depending on your activity level, depending on your genetics, allergies. The same foods affect bodies in a different way, right? And we've seen this over the last few weeks, this kind of idea that, there's no universal diet, very much contrary to earlier readings in the course, especially like Atwater and Lulu Peters. People are talking about calories and diet, and they treat the idea of human diet as sort of this one sort of thing, right, that everybody is subject to. There's one set of universal laws. And we're learning, as nutritional research gathers more knowledge, we're learning that that's really not true. And that's obviously the point of the Barabee article about obesity, is we can't look at it as one person is just not controlling their body appropriately, because there's just too many variables that go into why our bodies look the way they do. It's not just about eating too much or not running enough or whatever. Question 9. False positives tend to emerge for foods that resist easy estimation of amount, like ribs, salmon. There's 2 examples in the article. People give such a wide varieties of answers. Now, it's true that foods that resist easy quantification in terms of cups or tablespoons or whatever increase the inaccuracies related to those foods, for sure. Do they increase the number of false positives? It's possible they might, but generally, no, they don't. They make the survey less precise and maybe less accurate. It doesn't necessarily increase false positives. 10% of people got this right, so I want to make sure to emphasize this. The reason you get false positives, this is the main point of the 538 article. It goes back to question 1 about Judaism and raw tomatoes. The main reason you get false positives is because these surveys try to account for so many different kinds of foods and so many different variables. When you're doing that, statistically, you are going to get correlations. Let's say this is correlated with that. Judaism, raw tomatoes. Cabbages, any belly buttons, whatever, right? These things have no meaningful correlation in the world, but they show up. And it's not just because people are estimating things incorrectly or lying on the survey. It's just because that's a function of statistics. It has nothing to do with nutrition research. This is common to any field or any complex system that has a lot of variables. You're going to get noise. But false positives are from the sheer number of variables, not from inaccurate reporting. Although clearly, I think you'll understand that introduces its own set of errors. Question 10. The 538 article essentially concludes there's no such thing as a healthy diet. Now, you might get that impression if you're skimming through the article, you're looking at all these problems with how we study the relationship between food and diet. But the article doesn't suggest that at all, I don't think. It does suggest that we may not be able to quantify it, right? There's clearly skepticism that science, through the methods that are discussed in the article, are going to reveal or prove exactly what foods constitute a healthy diet or exactly what diseases they prevent or lower the risk of. It suggests there's not going to be any well-definable idea of a healthy diet. It doesn't really refute the idea that people can eat a diet that is more healthy than another one. Right? There's no skepticism that people can't be healthy through their food choice. How we figure out what that is, how individuals determine what that is, it's a different issue. To me, the article is suggesting that what's tricky about a healthy diet isn't whether or not it exists or whether we can do it, but whether we can really quantify it and measure it in the same way that other sciences do. Question 11, this is my favorite one. You can't trust what you read about nutrition. I said the answer was false. And for the first time, I do these quizzes all the time, and for the first time ever, 0 people picked what I said was the right answer, which means probably not a great question. So I'm not going to count this one. It was still fun. I'm glad I put it on there, but it's not worth counting for your actual score. Why not equally true and false? Most people put that totally defensible answer. So the reason I didn't put equally true and false is that implies to me that there's sort of an equal amount of trustworthy and untrustworthy information about nutrition. And that if I just give you an article about nutrition, you can look at it and it's sort of a coin toss whether or not you should trust it or not. I don't think that balance exists. I think there's a lot more dangerous, pernicious, uninformed, untrustworthy writing about nutrition than there is really good stuff. That's my view. So I don't think it's equally true and false that you can't trust it or not. The other reason I didn't put equally true and false is because whether you trust something or not has really, I think, nothing to do with the topic. So that someone is writing about nutrition doesn't automatically make it 50-50 whether or not you should trust it or not. Whether you trust something or not, as we've been looking at throughout this entire semester, is based on rhetoric, it's based on evidence, it's based on how you frame an argument, credentials, education, background. Whether they're writing about nutrition or not is sort of irrelevant. And just because they are writing about nutrition, and we know nutrition is difficult to study, I don't think lessons necessarily whether or not we should trust them. We've read a lot of things, I think, in the last few weeks about nutrition that I would say are pretty trustworthy. Did you trust the articles for Monday? Did you trust Barabee's article on obesity? They're all about nutrition. I think they're pretty trustworthy. Why? Well, they weren't making dietary claims. They weren't telling you how to eat. They were telling you about nutrition. There's a lot of ways you can talk about nutrition. You can approach it from a philosophical point of view, a religious point of view, a cultural, political point of view. You can talk about it in a lot of ways that aren't just, here's the latest fad diet. Question 12, the short answer question, how is the science of nutrition uniquely complex compared to other health research? How is it not? Here I was looking for just kind of a summary of the main ideas that appear in the article, and most of you did this totally fine. Looking at the complexity of variables. There's so many variables to think about. People don't report accurately. Long-term studies are difficult because people are eating so many different things. Isolating variables is impossible. Bodies are different. Genetics are different. Eating habits are different. People don't eat the same diet all the time, right? They might be more active in the summer. They might eat more comfort food in the winter, whatever. There's just so many variables that go into why we eat and what it does to our body at that particular time. In a way, those are unique. But on the other hand, we study lots of complicated systems in the world. Ecosystems in general, very complicated. Very hard to isolate variables in real nature, right? As opposed to taking a few things in a lab and isolating them from where they normally interact. Gaining data about or gaining knowledge about civilizations is really hard. Anthropology, for instance, history. So one unique difference, in my opinion, is that even though many fields in science are very complex, many have data collection challenges. What's unique in terms of nutrition research is that we want to have very precise, very accurate, quantified relationships between health and disease, because this is what we tend to do in medicine. We study the effects of drugs. We want to know this drug in this group of people produces this effect, right? We're seeing this in the news all the time with COVID vaccines. We want hard data about causal relationships that we can measure very precisely, repeatedly, and so on. But the way we study and the way we can study the relationship between food, diet, and health resists that kind of measurement. It resists that kinds of quantification. Think about history, right? Faces many of the same challenges in terms of studying the past as nutrition research does. Lots of variables, limited access to information. We try to find causal relationships in history. This caused this. This was an unintended consequence of that, right? But it's not about data. It's not about measurement. It's not about p-values and significance and so on. It's about telling the story that makes sense and help us understand the world in some qualitative way, right? In a way, I'm describing the difference between humanities and science. So my point here is that maybe diet, or the study of diet and health, is uniquely both in the humanities and in the science. Even if you don't agree with that, that's fine. I'm not here to convince you. But my point is to think about how disciplinary perspectives shape the way we think about diet and health, how it shapes the way we trust an article about it, how it shapes the way we decide to talk about it or decide what constitutes good evidence. What's more compelling to you, a really good story about diet or suggestive work, something like Barabee, where there's a lot of studies and there's a lot of research, but nothing is super definitive? Or do you want something that's very hardcore data? This causes this is the experiment, this is the lab report. There's so many perspectives about nutrition and diet and health, right? There's the biochemical perspective, which gives us very, very precise results, very accurate results, but harder to generalize into dietary advice. We have nutritionists, physicians, journalists, historical perspectives. These are all different and contribute different ways of looking at the problem, and in a way, I think, and reveal different blind spots. And this is where I think nutrition is kind of uniquely situated in terms of its science, because there is a very hardcore science aspect to it, obviously. But at the same time, there's also this element of storytelling I talked about in the last lecture, about how we talk about diet and health tends to be framed in these sort of stories because it's so hard to get an exact grasp on particular precise mechanisms. And so I think the history of diet and health shows us the value of thinking about nutrition from a very multidisciplinary perspective. And maybe that's a more productive path forward than trying to measure things in a more precise way or just making broad generalizations. Okay, so what are we supposed to do with this quiz? Well, as I hope you can tell, the main point here is really to facilitate discussion about the big points. So it's a little bit of a variant of the thing we've been doing before. I just wanted you to think about some of these issues ahead of time in terms of doing the quiz. Obviously, it's not strictly a reading comprehension quiz. It's just a little bit too slippery for that. But it does, even in its ambiguity, or because of its ambiguity, I hope, highlight some of the key issues that you can take away. 15 possible points. The highest, there was 113. Congratulations. Most everyone else got 9, 10, 11. So looking at the questions that most people got wrong, and everybody got some wrong, I'm throwing out the most commonly missed ones. And so I'm going to add 4 points to everybody's score. So whatever you got. And if that means you get 15 or beyond 15, then you get a couple points extra credit. Nice. Otherwise, that's your score. And I think that's a good balance of reflecting the work you put into the reading and then the quiz, as well as recognizing the fact that this is meant to be, not quite a standard reading quiz, but a way of doing the big points. So I hope that's helpful. Okay, take care.